All right, you guys, week 4. You've almost successfully completed this class, which is really exciting. We've had such an awesome panel of faculty each week, and that continues this week with a really diverse panel of specialists from different departments. So yeah, I welcome you all back. And for our faculty presenters, if you could possibly introduce yourself, maybe talk a little bit about your specialty, and this might be built into your presentation already. But just to give a quick rundown of who you are, what you study, what your interests are, so the students have some familiarity with you, and then we can launch into our lectures. So without further ado, we're going to start with Professor Prairie, who's in the Department of Environmental and Ocean Sciences. And so I will let you take the floor.
Thank you. Hi, everyone. I'm happy to see you all today and impressed that you're taking advantage of this opportunity to take a class before school has even started. So that's great. Okay, so I am in the Department of Environmental and Ocean Sciences. And if you want to learn more, please feel free to reach out to me. You have my email right there. You've actually seen a few people from my department already. Dr. Taddeo in the first week and Dr. Talley, I think, last week. And of course, this is right in the wheelhouse of my department. We study everything about the environment, and we have people with different specialties. My background is in oceanography, and I study plankton, like on SpongeBob. So I'm happy that SpongeBob exists, so you guys have a sense of what I study. I think otherwise, no one would know what plankton were. Yeah, what I'm gonna cover today is about the science of climate change. This is a huge topic, and I'm just gonna delve into the very basics. But I thought it was gonna be really helpful for you to see how does a natural scientist approach climate change and use information to help us communicate to the public the important aspects of it and to shape policy. We're not going to get into the specifics of policy today, and I think you've had other people who've touched upon that. But that is kind of the goal. And if you find this topic interesting, which I hope you do, since you're in this class on the environment, we offer lots of classes on this topic. We offer non-majors classes on this topic. And we also, if you become one of our majors or minors, we have classes that really go deep into this. So let me get started. And yeah, feel free to ask questions, and we'll have time for questions at the end as well. So the first thing I wanted to start with is what determines Earth's climate. I'm going to show a lot of figures, and this is good practice if you take a natural science classes, you'll have lots of figures like this. And sometimes like this, they'll have a lot of information, but I'm going to try to help direct you to the information that matters for the point I'm going to make. And so when we talk about what determines Earth's climate, we have what's called the heat budget, which are all the different ways that Earth can be heated. And in general, over very long periods of time, we consider the heat budget to be in balance. That means if you add up the arrows going in, they would equal the arrows going out. That's not the case with climate change, and so we'll talk about that. And so when we talk about climate change, what are ways that the Earth can be heated? Okay, well, there's 3 fundamental ways. And so I'm not going to talk about like the human causes yet. That'll be in the next couple slides. But in terms of these arrows, which of the 3 arrows going in can be affected either naturally or by humans? So that's first helpful to understand how our climate can be changed at a base level. Well, the first one is this incoming solar radiation arrow. Over our lifetimes, that arrow changes so little, but we will learn that it can change really small amounts. That does make a difference, that causes actual ice ages and interglacial periods, warm periods like we're in now. In addition, you can have the amount of heat that is absorbed by Earth's surface change, and that can change based off the reflectivity of Earth. So ice, because it's white, reflects more sunlight heat than something like pavement. So you can imagine how humans can be changing that over time. And you maybe have a sense of this when you wear like darker colors, maybe it's a little bit hotter, right? And then lastly, and this is the one that we're going to focus on today because it's the one affected most by humans, is greenhouse gases. And one thing that sometimes people don't know about greenhouse gases, affects the amount of long wave radiation that's radiated back to Earth, how much it gets trapped. So what you'll see is that when heat hits Earth's surface, it's re-radiated back into our atmosphere. And the reason it's affected differently when it comes in versus when it comes out is the wavelength changes. So, for example, different colors you see are different wavelengths of light. We don't have to get into the details here, but light has a range of wavelengths. And so this wavelength of light that's re-radiated back Earth is trapped by certain gases known as greenhouse gases, and that causes this arrow to come back this way. Okay, so those are the three fundamental arrows in our Earth's heat budget that can be affected. So let's dive more into this last arrow about the greenhouse effect. This is something that you may have heard about, and hopefully if you've watched the video that I assigned, you'll learn more about it. And so, as I mentioned, these are specific gases that trap outgoing long wave radiation from Earth. So it's not the same as heat that's coming in from the sun. That's a little bit funny. And so there are different gases that trap that, but that's not the ones that are being affected by humans so much. So what are the greenhouse gases? The one you've probably heard the most about, carbon dioxide. It's important for lots of reasons, primarily because we are affecting it so much. But other greenhouse gases we are affecting as humans is methane. I put the scientific notation in there. You don't need to know that, but I just put that in case you've seen it in another context. And then nitrous oxide. So all three of those humans are affecting very directly by burning fossil fuels and agriculture, land use change. So again, things that were covered in that video. And then the last one that is some people don't know about is water vapor. Water vapor itself is a greenhouse gas. That one can also be affected by humans, but because the water on Earth moves through our hydrological cycle, sometimes it's in the atmosphere, sometimes it's the ocean, it tends to not have as much of a net change as these other ones. It's not affected by the burning of fossil fuel. So although that one actually is the most abundant greenhouse gas, that's not the one that is as directly affected by humans, so is not as the focus. Okay, so some of that maybe you've heard before, some of it might be new information. So the question that we're talking about today is not just any climate change, but human-caused climate change. And so I want to introduce a word here called anthropogenic. Okay, anthropogenic means human-caused, and so that root anthro you might run into in college because anthropology is the study of humans, for example. Well, we have a language professor coming up next, so so that's what we mean when we say anthropogenic climate change. And so if you look at this diagram, again, a lot of complicated information when you're in classes. How do you distill what's important? Well, what I want you to see is that first, there's a lot of different ways that here this diagram is focused on carbon dioxide, that carbon dioxide can be moved around our atmosphere, our oceans, and our soil. And some of it is natural. For example, here's what I study, assimilation by phytoplankton. When phytoplankton photosynthesizes, it takes up CO2. Same with plants, right? However, this one is directly human caused. The combustion of fossil fuels. And so I think you've heard about some of these: oil, coal, natural gas, right? In addition, you see some agriculture here. And although animals have been on this planet longer than we have, right? Other animals, the amount of agriculture and the way agriculture uses land also increases those greenhouse gases in the atmosphere that I was saying. Okay, so that was a lot of information and a very quick rundown, but that's because I want to get into the meat of what's going on, which is how have greenhouse gases changed on Earth? So what do we know? So what I'm showing is actually the same graph that was in the video that you watched, and it is what's called the Keeling curve. It is the longest continuous direct record of carbon dioxide concentration in our atmosphere. It's taken at Mauna Loa Observatory. And so what you can see on the x-axis, so whenever you look at graphs, which maybe some of you have a lot of experience with, maybe for some of you that's relatively new. Either way, it can be tricky, and it helps to first orient yourself to the axes. So a good professor will kind of help you with that, but if it's something you're reading on your own, it's good to get practice. So let's look at the x-axis is time. So starting from just before 1960, which is when the record started, to the present day. And on the y-axis is the CO2 concentration in the atmosphere. Okay. And so I think even it doesn't take a lot of experience looking with graphs to see the general trend here, that it's clearly going up, right? It's got this kind of funny up and down effect that has to do with the seasonal effect. So you get it going up and down every year. This was only kind of explained in the video, and I think this is a fun fact because often we find that seasons, there can be a lot of misconception about what causes seasons. So at first glance, it might not be obvious why there's a seasonal cycle. Because as the video explained, there's a seasonal cycle because of when land plants take up carbon dioxide through photosynthesis during the summer, there's less CO2 in the atmosphere as those plants you can think of as breathing in that carbon dioxide. But the reason it's not obvious is why is there a seasonal cycle? Because in our summer, it's the southern hemisphere's winter, but when it's our winter, it's the southern hemisphere's summer, right? And so the reason is because land mass is not evenly distributed on Earth. Most of land mass is in the northern hemisphere, and so it's a northern hemisphere summer signal. Um, the fact that we have so much land mass diverted to the northern hemisphere has that kind of effect. So here we can clearly see it going up. And you might think, okay, well, here we already have evidence. But I think it is reasonable just looking at that graph to say, well, this is just since 1958. What does carbon dioxide look like in our atmosphere over long periods? Like, is this a lot, right? How much is this going up, right? I think that's a very reasonable question. So let's take a look way back in time. This graph, which has got a lot of going on, but I'm going to orient you, is from ice cores. And it goes back 600,000 years. So on the x-axis, it's time again. And this 0 is current day. Okay. But then this is in thousands of years. So this is 100,000 years ago, 200,000 years ago, all the way to 600,000 years ago. In fact, ice cores we have now actually go back to over 800,000 years ago. So this one's a little bit shorter of a graph, but it's a cleaner graph than some of them. So I chose it. So this is showing way, way back in time. Okay, we've got 4 different lines on this graph. What are they? What's happening? Well, the first is the red and the blue are 2 of our greenhouse gases we talked about. Red is carbon dioxide, shown on that left axis. This one's really confusing because there's 4 different y-axes. So I'm going to point those out. And the blue is methane. Okay, so these are over time concentrations of these greenhouse gases in our atmosphere. And then the black and the gray are showing kind of the same thing. They're both proxies for temperature. So obviously humans weren't recording scientific data 300,000 years ago, but we can, from the ice cores with little bubbles of gas trapped in them, we can get what's called a proxy for temperature. And these are 2 separate proxies for temperature. So what can we see? Well, first of all, we can see that sure enough, temperature does go up and down. So this is not like in degrees Celsius, right? So but it's relatively up is warmer, down is colder, okay? And so even before humans were burning fossil fuels, which has only been happening in the last couple hundred years, we still got this up and down signal. And this, when it's colder, this corresponds to ice ages, all right? And these gray bars, when it's warmer, are what we call interglacial periods, i.e. warm periods, okay? And hopefully what you can also see is that the carbon dioxide and the methane go up when the temperature goes up, and they go down when the temperature goes down. So they're strongly what we call correlated, right? They go together. And so it seems like there's a pretty clear link, and that link is the greenhouse effect that we talked about. So when you look at this, you might think, well, Dr. Prairie, it goes up and, there's some common myths we're going to talk about in a little bit. It goes up and down. So why is it concerning that it's going up now? Well, let's take a look at what our values of these greenhouse gases are in current day. This ice core record doesn't show the last, since Industrial Revolution. So if you look at this y-axis where it's carbon dioxide, I don't know how many of you have a very sharp memory and remember that that number was over 400 parts per million. So if I'm going to plot that on the graph, I have to extend my axes up quite a bit. And here, it's literally off the chart, right? So this is what current carbon dioxide looks like. This is what it looks like the last 800,000 years. So over the last 800,000 years, it's never been above 300 parts per million, and this is what it is today. Methane, similarly, is over 1,900 parts per billion. So I made a little more axes here. So this is concerning. Hopefully this should be shocking and concerning to you. This is not, and no one debates these numbers. These are known records, right? Some people are just, for some reason, not concerned about this. So this is kind of the context. All right. So what I want to spend the rest of the lecture on, and as expected, this is a lot of information. So this will be quicker than we want, but hopefully, again, it's going to give you a little bit of a taste, is how can we use natural science to debunk common myths about climate change? Because at the end of the day, what my goal is to do is to provide you with information to go out there and be informed voters and tell your friends and think about this stuff and take more classes, right? Ask good questions. So you hear a lot of stuff in the media, in the news by friends, because it's out there, it's confusing. And part of the reason this is a problem is because natural scientists are not trained to speak to the public, at least in traditionally. That's something that's changing more, and something that we're really valuing now is super important. And there's people, not only professors and researchers, who are getting better at talking about that, but also people whose whole job it is to communicate natural science to the public. And so that is really, really important. And some of these myths are fueled by the fact that in the past, scientists were not very good about talking about this. And so it's now our job to really try to break this down and make it as understandable for people as it can. Okay, so let's go. I'm going to go through 4 myths. There's certainly, you could come up with more of them, but I'm going to go through 4 of them. One of the ones I hear the most common is someone will look at the graph I just showed with those glacial and interglacial cycles, those ice ages and warm periods, and say, well, climate change is natural, so it's not caused by people, right? This is a very common one we hear. And going on along with this myth is this kind of idea that, like, scientists don't understand what causes ice ages and interglacial periods, that we don't understand that. But that's not true. That past record I showed you, where it goes up and down, climate scientists have a very strong understanding of what causes those natural cycles. It has to do with Earth's orbit. So this is a picture of Earth, and there's tiny, tiny, tiny changes in Earth's orbit over the course of 100,000 years that triggers these ice ages. So one is our orbit around the sun is oval, it's elliptical, it's not circular. And sometimes it's a little bit more oval, and sometimes it's a little bit more circular. So that change. Sometimes, so we're on a tilt of, our Earth's tilted 23.5 degrees. That's why something you learn in my classes, if you've heard of like the Tropic of Cancer and Tropic of Capricorn, it's where the sun is directly overhead. That's because of the tilt of the Earth. So that tilt of the Earth over long periods of time changes by a couple degrees. And then also the timing of the year when the Earth is closest to the sun changes. So all those things change by a little bit, enough to trigger ice ages and warm periods like you saw on the same graph. However, and because we understand this really well, we can make models to show what it would be. What would it be if it was just due to this? And so here I'm showing a model. A lot of the data I'm showing you is from what's called the IPCC report. And I'm going to show you at the end what that is, but it's basically the consensus of scientists who get together and write this. So here, this is from 1850 to 2020, and this is in degrees Celsius. A lot of times as scientists studying climate change, we don't use absolute temperature, but we use change in temperature. So this 0 degrees is the average temperature around 1850, and this is how much it changed since then, right? So this would be a 1.5 degrees. So observed, it's what's showing in this black line. Okay, so you can see this black line goes up and down a little bit, but here's the trend we're seeing now, where it's a clear increase. And these scientists made two models. They made a model that include only the natural causes, i.e. those changes due to the changes in Earth's orbit. And that's what's shown in this green. And the reason there's a kind of thickness here is like, okay, even with a lot of uncertainty, considering all the possible ways we could be wrong, we still are very certain it's within this green bar. And then the brown is if you take into account both this changes to Earth's orbit and human anthropogenic causes. And what you can see is this green line does not explain the observed change. Only when you include human causes does it include that. So that is really indisputable, and it's agreed upon by the vast, vast, vast majority of scientists, like greater than 99.9% of climate scientists. So that's one myth. Okay, so the second myth is that kind of stems from that one is that scientists disagree about climate change, and then there's a lot of uncertainty about climate change. So you hear that all the time, and the media doesn't help us with this because they'll bring in like a panel of people to talk about climate change, and like one person will be a climate scientist, and then like four people will just be like random people on the street, right? And who have like, you know, opinions that are against the climate change. So they'll try to kind of make it sound like, oh, it could be either way. This is not a correct representation of the science or how much scientists agree on this. I talked about how sometimes scientists are bad at explaining things and can cause misunderstandings like this. And one of the main ways we've done that is with the concept of uncertainty. So we talk about uncertainty in science, and you'll hear them talk about it in the media. But uncertainty is a specific term in natural science that does not mean lack of understanding. And in fact, all good science should quantify uncertainty. And that's because we recognize that we are learning about the world from sampling, from incomplete data. We can never sample the entire world. You learn about that in my statistics class. And so we quantify uncertainty to have a better predictive power of the range of potential outcomes. But it doesn't mean we don't know things, that we're ignorant about things, or we don't have any idea. That's not a correct interpretation. So to give you an idea about what quantifying uncertainty looks like, I have another graph for you. Again, I just want you to focus on some of the details here. So this first bar graph, this is both of them, these bars are in degrees Celsius, so the amount of warming. So this is what we've observed. And so the gray bar is the average of what we observed. But then do you see these like this thin line that goes up and down? Those are called error bars. Okay. And these error bars show, well, you know, we've taken these measurements from different places and at different times. And so considering all of that, we are 95% confident that the true amount of warming is between these bars. So between like 0.8 degrees and 1.2. Notice though, considering that uncertainty, it is still very, very much a lot of warming. No one is saying, oh, it's 0 degrees, right? It's with the uncertainty, it's still very warm. In the same way, when we look at, is it caused by humans, right? Well, here, there's the different factors that humans cause. And so the most striking cause that humans have is the second bar, which is greenhouse gases. So that's our effective greenhouse gases. And sometimes this is where you often get misconceptions. People will say, oh, there's ways that humans are cooling Earth too. That's true. And that's this. That's because we're also messing with cloud formation and other things that do affect that incoming solar radiation. But importantly, when you add up all of these bars, you get this first bar. Okay, so this is the total human influence. And you can see it matches very well with what we have observed. And even when you consider the uncertainty, we still are very, very confident that there's warming. No one thinks there's no warming caused by humans. Okay, I got to speed up probably a little bit here. Okay, so third myth is that you'll always hear this. You saw on the last graphs I showed, we're talking about a little over 1 degree warming that we're experiencing right now since the industrial period. And so people say like 1 degree, you even see people like, that's great, I like it warm. I look forward to it. You hear that, that a lot. And the problem, and then people say, oh, it'll be years until we see the effects, which I really think those people aren't looking at the news. But let's take a look at some of the effects we're seeing, because even though 1 degree is not a big deal to you personally, you can change your thermostat to be a little more air conditioning, right? That's kind of how we think as humans with electricity, I guess. 1 degree, when you talk about how the atmospheric circulation works and the ocean circulation works, is huge, right? So we're not talking about the fact that, oh, it's a little bit warmer and I need to, wear a tank top, right? This is not the type of thing we're talking about. We're talking about how on the global scale. So some of the effects we're seeing, and by say we're seeing now, these are all things now that are happening. Habitat loss. I'm showing polar bears because it's people's favorites, coral reefs, but you can choose almost any organism and there's habitat loss. So, there's some examples. Heat waves that are killing tons of people. Fun fact, I grew up in San Diego. No one had air conditioning like west of the 805 freeway when I was growing up. And now it feels very necessary for months of the year, right? So I see it in my lifetime. Okay. Flooding. This is a picture from the really bad floods in India several years ago, but we have them in the States now. This is another thing is people think like that is a distant problem, someone else's problem. No, in the States as well. And although you should care about the whole world, but yeah, everywhere this is happening. And that's because even though greenhouse gases have a very direct effect on temperature, it's increasing, they do weird things to precipitation. Precipitation in some places increases and in some places decrease. And what happens is we get more of our precipitation all at once with climate change. Okay. And then hurricanes, complete disaster. This is this is from the Bahamas in 2019, but you could pick any year. There's stories like this, right? And it's devastating. I mean, these are Category 5, terrible, terrible hurricanes. And hurricanes require warm water, so we typically don't get them off the coast of California. But we are changing that. We are now getting hurricanes off the coast of California, so that's fun. Fires. So if any of, I think some of you are probably from California, or honestly now any part of the United States, Colorado, right now, Canada, all of Canada was on fire a couple of years ago, Australia. This is a huge, huge deal in California, and it is 100% fueled by climate change, as is drought, right? So I talked about the redistribution of water, and in California, that's a big deal. So this is just, this is depressing and just a snapshot, but anytime people say it's not a big deal, that is ridiculous on its face. Okay, the actually most insidious myth is this one, and it's the one that I'm hearing the most now, is it's too late to do anything about it. So people who were in this camp went straight from it's not happening to it's too late to do anything. And this is actually the one that's most destructive because it stops any policy change from happening if people buy into this, right? And so what I want to show you now, and this is again, a lot of graphs, but it's just to kind of get you exposed to that. In this IPCC report I was telling you about, they showed 5 different scenarios. On this x-axis, we have time, but what's different about this axis is it's going into the future. So starting now, a little bit, this was a little bit 2015, and going to the year 2100, so showing the future. And here on the y-axis, it's showing carbon dioxide. And then they have another graph with those same 5 scenarios going into the future and what temperature would look like. And so here you can see 0 degrees up to 5 degrees C of warming. So what are these 5 scenarios? Let me go over a few of them. This brown one, burnt sienna, I'm going to call that color, is this. We do not want the scenario. This scenario is if no one cares, no policies are enacted, we keep doing what we're doing. So you see on the right, CO2 keeps ramping up. So not the amount of CO2, but the rate that we're putting CO2 in the atmosphere. This scenario would result in over 4 degrees of warming by the year 2100. Okay, this is a disaster. The orange one is, we take some policy changes, kind of middle of the road. So carbon dioxide does continue to increase the rate, but by 2050, we start to decrease the rate of it, but we don't reach net zero until the end of the century. So it's kind of middle of the road. This would result in 2.7 degrees C of warming by the end of the century. Again, we're at about 1 degree right now. And the most optimistic scenario is if we get our act together and internationally, we're making policy, we have these Paris Climate Accords, we have important things, and we cut emissions to net zero by 2050, we could keep it to 1.5 degrees C of warming. So yes, all these scenarios result in warming. I promise you 4.4 to 1.5 is a huge difference. This matters. That's what I want you to take. So what you do, what you vote matters, right? Okay, so I'm going to end it because I'm talking too much. But if you want to know where you can get information, I don't know if we're posting these. Oh, well, you'll see the video, the recording. The Intergovernmental Panel on Climate Change is where a lot of this data come from. It is every 6 years or so, they produce a report. It is hundreds of scientists, climate scientists and related scientists from around the world get this together to publish this. The full report is over 1,000 pages. I don't recommend reading it, but it's free and you can download it. But what they have is they have a summary for policymakers that is like 20 pages. And if you want to kind of get snippets from it, you can kind of see the data. The data is free and available, is my point. If you want to know more about San Diego, what's going on, there's a climate education partners, and it's actually run out of USD, which is cool. And it's where leaders in San Diego are making policy and kind of reporting the information that's relevant to San Diego. And then these common myths, a lot of them I pulled from this UN Environment Program. You might hear about like the UN Sustainable Development Goals. They're coming from here. So with that, I'm happy to take questions, but I took my full half an hour. So I think we will switch over and then at the end, I can take any questions. Thanks.
Thank you so much, Professor Prairie. We're going to move right along. We're doing fine with time. But without further ado, Professor Medina.
Hello, greetings, everyone. Thank you, Eliza, for coordinating, and Jenny, thank you for putting us in the beginning, in the middle of the question. I'm Julia Medina. I teach in the Languages, Literatures, and Cultures department, and I specialize in Latin American literature and culture with an emphasis in critical theory, and my research focuses on environmental humanities. Oftentimes, students don't know what humanities do, and we live in a time of history where humanities is also underrated or misunderstood. And so I hope this gives you an opportunity to see and understand how humanities can help us also address this huge problem or issue of climate change and environmental devastation. So as part of that introduction, before I begin talking about creation stories, I want to first acknowledge that the land in which I am sitting, because I don't know where you're all at, but at least San Diego, is a traditional and unceded territory of the Kumeyaay Nation. And I want to pay respects to the citizens of the Kumeyaay Nation, both past and present, and their continued relationship to their ancestral lands. So that's just as a form of introduction and of respect to recognize also what our relationship is to where we stand. And so with that in mind, I will begin sharing my presentation. I just want to start with this line from Robin Wall Kimmerer, who you all read for homework. And she talks about how we are the same species, we share the same earth, have different stories. Like creation stories everywhere, cosmologies are the source of identity and orientation to the world. They tell us who we are. We are inevitably shaped by them, no matter how distant they may be from our consciousness. So cosmologies here means basically the study of the universe and the origins of the universe, and on the large scale, like galaxies and when that all happened, right? And so picking back on Dr. Prairie's presentation, I want to start with, even though it's not a story, but it is a narrative, I want to start with science. And science is an epistemology. And here we go back to more vocabulary words. And epistemology is a way of knowing. And so science is a way of knowing through facts and data of the material world, right? And according to that story, our universe began with a Big Bang around 13.8 billion years ago. And then the Earth itself was created around 4.5 billion years ago from all the matter and particles and gases that happened during that time. And then bacteria-like organisms start to create to unfold on the Earth about 3.5 billion years ago. And from there on and on and on and on, we come to the evolution of different beings and species until we reach the human condition, right? And so more or less in a the story, the scientific story of how the humans how the universe was created, and also how humans come to inhabit the world, right? So now it's interesting that even though this is science, right now science is in a crisis with the narratives of religion and creation, right? And so there's a midway step right now happening, which is called creation science, which I'm not familiar with, but I guess it's a form of science that tries to explain creation, justify creation stories through science. Anyways, that's a whole in between point between the actual science and the creation stories that I'm interested in talking about today. So I want to start talking about creation stories with the creation stories that most of us are familiar with, which are the creation stories of the Judeo-Christian tradition. In that story, oh, I'm going off script, so sorry. So basically, now in looking at these stories from the vantage point of cultures and languages, this presentation is an invitation to decenter the human when reading, analyzing, or representing the world. So that includes also these creation stories. How do we read creation stories without just looking at how humans are created, but also how non-human are created? Both living and not living, meaning lakes, mountains, rivers, not just animals and humans, right? So creation stories seek to explain the existence of the universe and humans in it. So how is our relationship with the environment conceived in the creation stories of new worlds and in the Western imagination? Our relationship to the world is influenced by these stories, whether or not we like to acknowledge it, right? So I already started with science as a narrative, and now with the Judeo-Christian tradition, the creation story can be found in the book of Genesis, which explains how humans came to inhabit the earth through the work of God on the count of 6 days. On that sixth day, after separating light from darkness and air from water, Adam was made from the soil. In the Christian tradition, God willed Eve, the female, out of Adam's rib to keep him company. The place and the setting of the human was the Garden of Eden, where all was plentiful, and the only forbidden thing was a tree, a fruit from a given tree. With different titles and names, the Quran creation story also follows a general the Judeo-Christian tradition, with the difference that with different names, Eva is Ewa, and God is Allah. And but these three major religions, Judaism, Islam, and Christianity, or they all share the monotheistic characteristic, meaning there's only one God, right? The difference, one of the biggest difference with Islam in this case, is that water is the essence of our life, and living things come out of water. So that would be like one of the different of the small differences. But other than that, in addition to monotheism, meaning the only one God, there's punishment from God for eating from a specific tree, despite the fact that Adam is made out of soil. And then, the snake is seen as evil because it tempts Eve, who's the one who leads to this eating. And then Adam and Eve get thrown out of this garden with this bountiful world, right? And so, anyway, so the stories focus on the human agents and what happens, right? Now, in Hindu creation stories, it's a little bit more complex because the first man, also saved from a great flood, appears as a fish, and a fish appears and saves him, and the boat carries him and seven other sages. So there we see kind of more of a step with a collaboration with other species in the ideas of creation. Okay, so with that recap of creation stories that you are all familiar with, I like to turn to indigenous creation stories, especially indigenous to the Americas. And I want to start with this part of the world, North America, also known as Turtle Island by indigenous groups. As part of your homework, you read the creation myth of Sky-Falling Woman, part of the Haudenosaunee people, the Iroquois people. And so, although I had already heard the premise of the Sky-Falling Woman, the first time I read it was from Robin Wall Kimmerer in her 2013 book, Braiding Sweetgrass: Indigenous Wisdom, Scientific Knowledge, and the Teaching of Plants. So in that book, Dr. Wall Kimmerer bridges scientific knowledge, or that epistemology, right, with the indigenous cosmology, because as a Potawatomi person. And so she quotes, "In the beginning, there was Sky World, a plane that exists beyond the physical world, and it relates to the creation and spiritual, a place of origins for humans, animals, and Earth itself. She who falls from Sky World to bring life along with the alchemy of the animals' gifts, coupled by her deep gratitude, is what actually creates North America." So in that story, and that's a quote I had just read from the story of the creation of North America, right? In that story, geese is the first to appear on the scene, and the geese symbolically connects the air to the earth, and the loons show up, and the otters, and the swamps, and the beavers, and the fish, etc. And of course, the great turtle, which offers his back to this woman, and that's basically North America, right? So it's this collaboration between animals and human. In this case, the human is a female, right? There is not a male. So it's interesting that this creation story is part of the oral tradition, right? So meaning that this is a story that is told from generation to generation. It's not knowledge in the scientific sense. It's cultural. It's cultural knowledge, right? So how do we deal with this, and how does it relate to, our understanding of science and so on? But what we can take out of it is that this creation story also not only explains the origins of North America and all the different species that live here, but also it gives us a blueprint as to how to go forward in interspecies collaboration, right? How can humans exist along with other species, creatures, and beings that are also non-human, okay? So that's one side of North America. I want to speak of another part of North America, which also is Central America. And I also want to look at a creation story from the Mayans, the Popol Vuh, which is an indigenous text, and it means the book of the people. Now, unlike Sky Falling Woman, which comes from the oral tradition brought down to generation, the Popol Vuh is a colonial text. And it's a colonial text because it was found written in Latin letters. Latin letters is what you and I read, but in Quiche, which is one of the indigenous Mayan languages. So the book that was found in the 17th century was basically already a translation of Quiche into Latin, right? Because the Mayans are the only American indigenous society that had a complete writing system. In schools, we're taught that there was no writing systems in the Americas, but the Mayans actually are the only civilization in the Americas who had a complete writing system. There's only 5 individual writing systems in the world, and Mayan is one of them. And so this book was already translated from the Mayan glyphs into the Latin glyphs, but in the Quiche language. So then it had to be translated again into Spanish and then French and so on. The reason I'm telling you all this is because even though it contains indigenous creation story, it also has seeped into it some of the Christian story that you are familiar with, as you might have detected from the short little clip that you saw, okay? Blending both Christians and indigenous creation stories, the Popol Vuh shows us 2 or 3 gods, Huracan, which the word hurricane comes from here, right? And it also, another name for him is the heart of the sky, and Cucutzman. Now, it's interesting that in this creation story, the gods are natural forces, right? Similar to the first creation story that we read. The gods order the waters to leave the earth so that there can be land, and then birds come, animals, trees, and because actually trees come first, pardon me, trees come first and then animals. And then because animals could not speak the gods' names, the gods punished them, as you saw in the video, so that they would eat themselves, right? And in quest for more obedient beings, they make men out of clay. and men out of clay were destroyed because they were no good, and then they make men out of wood, but the men out of wood had no soul, so then they were destroyed, and the kids of those wooden men turned into monkeys. And the video is not very clear about the sequence, but after those second failed attempts of men, the twins Hunakpu and each Balanque, those two twin brothers that play with the lords of the underworld, they basically go to Xibalbá so that they can save their father's spirit. Their father was the god of corn. And so, as you can see from the video, as you saw in the video, the lords of Xibalbá, the lords of the underworld, sent these different animals, the owl, the flea, the frog, the snake, the gavilan, to give messages to the brothers, and so that they can communicate. So the brothers, after all their trials, they end up winning, and their father, the spirit of their father, the corn, is brought back to the world, and these brothers become the sun and the moon, right? And so now that the god of the corn is liberated, all of the animals get together and collect the corn and bring it to the gods, and that's how the gods create the human. So humans are created from corn based on the collaboration of the animals that are bringing this material to the gods. So then that's why, in Mayan cosmology, corn is a very important, form of substance, because it's also what creates the flesh of humans. Um, so in this story, then what we see is, like in the story of the sky falling woman, we see interspecies collaboration. That means, it's not just humans or supreme beings creating things, but it's also non-human that are part of the creation of humanity. And also there's a horizontal relationship between, it's not a vertical relationship between humans and non-humans, but it's also a relationship of understanding and of equality. So the creation stories of indigenous people create what is also known as ontology. Ontology is another SAT word that you will need at college. What is ontology? If epistemology is a way of knowing, ontology is a way of being, okay? And so we often think that there's only one way of being, which is our way. But that narrative is also false, because it basically disregards the ontologies that indigenous stories and narratives tell us about how we relate to the world. Okay, so so with that being said, I want to also, to connect the Americas, because the Americas is a whole continent. I want to take this also down to South America and let you know about one of the most I don't know. I think this is one of the few indigenous people that were not colonized by the Europeans, and they're the Mapuche, and they still exist. Mapu means world, Che means people, so it's people of the earth. And their creation stories entail two siblings, a boy and a girl, who are helped by a fox after a flood, and that flood is created because of a war between these two serpents, and so on, right? And so the Mapuche people right now are suffering enormous aggressions with extractive economies that are pushing mining, that are pushing deforestation, that are basically, to produce lithium batteries and things like this. And so there's 2 million Mapuche people still alive in the world today, most of them in Argentina, in Chile, and also in part of Argentina. And they provide with a very fascinating understanding of the world, as their vocabulary and language even captures these different forms of being, these different ontologies. Okay, so the UN Secretary Antonio Gutierrez this year is correct in stating that, and I quote, "The world has much to learn from indigenous people's wisdom, insight, and approaches," end of quote. So, and the reason why the UN Secretary General said this is because precisely the devastation that we're seeing at a global scale because of the destruction happening in the world with anthropogenic actions happening, right? So how do we use these creation stories then to help us solve that? First of all, by being able to put things on the spectrum, right? And in that regard, I want to go back to the beginning, which was science. So as an science is an epistemology that we use now that is based on Renaissance understanding. So the Renaissance is a time period during European development, right? And so the Renaissance can be captured by a philosophical statement that you all might have heard, which is, I think, therefore I am. Cogito ergo sum by René Descartes, right, from the 17th century. And so that is the basis and the principle of the Renaissance understanding, which is at the root of scientific knowledge. Now, this foundation of knowledge posits the act of thinking as proof of existence. So thinking is proof of existence. So this is the foundation of Western humanism. What is Western humanism? Western humanism is where we all are. That's what our education system is based on. It's based on this principle of I think, therefore I am. And so this is also an ontological realm. This is the ontological realm that we are used to recognize, and it's the only ontological realm we recognize, which is only sentient beings matter, only beings who think matter. I think, therefore I am. And so it's also based on individual premise, right? So there's an individual that thinks and is, right? As alone and disconnected from a cosmos. And so if this is the Western humanism that gave rise to the episteme of science, which is the science that we use, I'm looking at ecology, for example, which is one of the places where we could think about, along with environmental science, one of those places where we can think about, perhaps changing or understanding better what's going on. Now, the etymology of the word ecology is home, the study of home, right? The earth as a home, something that we've lost sight of, even though the wording and the etymology of the word uses it, home. It is not within the Western humanism, home loses a meaning of a common meaning that is shared by others that are not just human. So because the Renaissance and colonization happened in parallel times, Western humanism was constructed in opposition to indigenous worldviews. And in this sense, what we're doing is we're basically moving on with a colonial mindset, right? So we've never talked about or thought about indigenous ontologies and indigenous ways of being because it doesn't go along with I think, therefore I am. So with this in mind, I want you to think about origin stories and their interest to our present. So in this presentation, I want you to think about creations, origin stories from the Western imaginary beyond the mytho-religious categories that we've just read. And I'm thinking, before, pardon me, but this is the humanist in me going back to my to the PowerPoint, but ecology as a science, is it anthropocentric, right? Anthropocentric, anthropogenic, meaning humans are the causing agents of destruction. Anthropocentric meaning humans are the center of the world, right? So basically that's where Western humanism leads us. That's where we are. That's what we think. We think of humans in a pyramid, right? Humans at the top, whereas indigenous ontology sees a circle rather than a triangle, right? And humans are part of that circle, not on top of the circle. So anyways, but let's look at how Western humanism depicts other creation stories. And let's look at fiction, because fiction is part of the imagination of Western humanism. And I'm thinking, for example, of Dune and Avatar, which many of you are familiar with, right? And the creation stories of those mythical worlds are basically allegories of the colonization that we're speaking about right now. So by learning to consider how the relationship between humans and their surroundings have been represented, constructed, and contested in creation stories, you are invited to interpret in what I'm sharing with you, our own context, and to imagine other futures that could restore the dignity of our common home. The relationship between my presentation and the call for action is that interpretation and understanding are necessary steps to executing actions. And if action begins with individual change, then my presentation is compelling you to interpret the world beyond the human so that we can recommon the home that has been decommoned by the rest of the species in our planet. So we can take questions afterwards.
Thank you so much, Professor Medina. We're going to move right along for the sake of time, but again, get your comments and questions ready. I'm already seeing a lot of really cool overlap between our two faculty presenters. So that brings us to our final specialist, Professor Wissman.
Okay, unmute there. Okay, I'm very excited to be here, especially since you all are incoming freshmen. So we're going to talk about business, the business perspective here, and it links quite a bit to Dr. Medina and Dr. Prairie's work. And I want us to think about some of the issues about the environment that are embedded in business. We don't often think about sustainability necessarily as a significant business issue, but today I'm going to make the case that it really is. It's something that's very important. It offers an opportunity as well as a threat to companies. So a little bit about my background. I broadly study climate impacts and climate risk, particularly around mitigation. So how we are reducing and decarbonizing our economy, and as well as adaptation, how we're preparing for climate impacts. I do this in my academic research, which means your professors are often publishing papers and doing research that they bring into the classroom. So that might be 50% of their job, as well as working with local governments such as the City of San Diego, SANDAG, and the County of San Diego on issues such as integrating equity in their organizational processes around their climate action plan. So how the county, for instance, is going to approach more equitably its climate mitigation strategies. And we also have the Environmental Integration Lab here at USD, and our work here is to really establish collaborations among faculty, as well as create programming for students to help you all engage. You can follow us on our Instagram if you're interested in engaging on campus. We'll have film screenings this year. We have folks come from a variety of different disciplines, from the film industry, from documentarians, and local companies that come and speak to students. So the best place to find our upcoming events is on our Instagram or our website. Okay, so the big question that we're gonna grapple with in this talk today is, what does it mean for businesses and organizations to act responsibly in a world already shaped by climate disruption and systemic inequality? So what does it mean? How should business act? And Dr. Prairie did a really good job of kind of outlining this big issue that we're facing around climate change. And we've had this goal of staying under our 1.5 degree limit, but we're not going to make it there. So UN projections say that we're projected to increase our global greenhouse gas emissions by 2030 compared to 2010, rather than meeting our 45% needed reduction by 2030. So what this means is that we do, as Dr. Prairie pointed out, we do have a lot of hope here, but we need to act much more quickly than we are. And what we can see here is that, so picking up again from Dr. Prairie's work here, is that we can see that carbon emissions have drastically increased over the last 30 plus years. So this is from the Institute for European Environmental Policy. So in the last 30 years, the amounts of CO2 emissions have increased at a rate faster than ever before. And they need to be reduced twice as fast by 2030 in order to stay under 2 degrees Celsius. So we have a big lift here. And what I want to show or point out here in this graph is that there are kind of 2 anomalies here when we're thinking about just the trajectory of carbon emissions. We can see that there's a financial crisis, so there was a reduction in emissions going up, as well as with the COVID-19 pandemic. And this is important because what it really shows is that our greenhouse gas emissions, and we often just talk about carbon emissions because we have a carbon equivalency. We can see here that it's really deeply connected to our economic productivity. So what really slowed down here during the financial crisis is that we weren't producing as many goods and services as well as during the pandemic. So we call this tightly coupled or correlated with the overall economy. So we want to think about that idea is that when emissions are going up or when our economy is going up, so are emissions. And you're hearing a lot about the electrification of our of the way that we do things, such as electric vehicles or transportation systems, or moving away from gas in our homes. And part of this is the idea is that technology will be an intervention, that technology can uncouple our economy from carbon emissions, that we'll be able to have our economy continue to grow and carbon emissions to come down. That is the ideal, and technology plays a significant role, but there are other perspectives, such as donut economics, saying that we really need to kind of think about restructuring our economy, or ideas around slow growth, slowing down our economy so we can meet our reductions. But all of those require a lot of sacrifice in order to meet our carbon, or to meet our emissions reductions goals. So this creates a significant problem for business, around ethics, the way that we do things, and how we're going to meet these needs. So we have and are prepared for a climate change future, but are also moving to strongly reduce our emissions. So the role of business here is really, it's both a cause of some environmental problems, particularly climate change, and we're also going to talk about plastics today, as well as providing a potential solution to environmental problems. So innovations, new ways of doing things, new ways of producing goods, or new ways of producing plastics, such as biodegradable plastics. So businesses here can really reduce or make less waste, use resources wisely, work to kind of treat workers fairly when we're thinking about equity and we're thinking about some of these human issues in business. And they can work with others to solve problems. So they can work with local governments in order to create solutions, and they can also be honest about impact. So when it comes to climate change and when it comes to issues such as waste with plastics, business has not always been honest about those effects. And I can put up some resources around that, around kind of these big campaigns around manufacturing denial around climate change, as well as being very optimistic about the ability to recycle plastics when the industry really knew that we couldn't recycle plastics to the extent needed. At its basis, business really is transforming inputs into value. It's value creation. So we're taking raw materials and we're using the value chain of a company to make something of value that produces a profit for that company and produces something of value for the customer. And this traditional model can really be seen in terms of the linear economy, that we're taking these raw materials that are embedded in our Earth system, and we are producing, distributing, consuming, and disposing of these materials, and it produces waste. We often haven't thought about what to do with that waste or how that waste can be repurposed and reincorporated back into our production cycle. And we'll talk more about that in a few minutes. And that was also part of your video that you watched with the Ellen MacArthur Foundation. And this is really important to think about, is because we need to think about Earth as a system, that Earth is finite, and that we have to think about systems being able to regenerate themselves, to be able to sustain. And we're really human society is overshooting Earth's carrying capacity, or its capacity to regenerate itself. And we'll talk about plastics here. So I want to ask you this question. We have a big issue around responsibility. And right now, there's a UN-led or United Nations-led convention on plastics, how we're going to manage them internationally, what are the standards here, because it's a significant issue. And I want you to think about it. You can think about just going about your day, how many pieces of plastic you might touch, but also kind of how it's really embedded into what we consume. So I want you to think about how many packages have you ordered this month and how much plastic came with them and how much we're really consuming. So we can think about these as externalities. So externalities can have, they're really things that are not included in the transaction cost. So if you go to buy a water bottle at the store, you are getting that water bottle, but that water bottle is not included in that transaction cost. So you're going to go and you're going to either hopefully recycle it or you're going to throw it in the trash. So that water bottle essentially has an effect on a third party, and that can be a positive or negative effect. In the case of a water bottle, that is going to be a negative effect. So it's really not accounted for in the transaction cost. So that third party here is both the environment and as well as humans that are being affected by that externality of plastics. We can think about it in carbon emissions, that it's contributing to climate change, but we can also think about it turning into microplastics, or the fact that less than 10% of all plastics produced globally have been recycled. It can be very difficult to recycle plastic. There aren't really good well-established recycling for all types of plastic, and there are lots of issues around why plastic is not recycled. But it's getting into our food system, and it's also getting into our bodies. We're detecting it in our oceans, in our rainfall, and it's really everywhere. So it's a significant issue. So other examples of externalities are those carbon emissions, other types of e-waste. You can think about how many cell phones you've had, electric toothbrushes, any sorts of things there, and really the end of life of a product. So in that linear model, that there's a product that is going to waste that's not really incorporated back into or accounted for monetarily, and it can cause disruption to natural systems. So there's this idea in economics called the true cost of plastic. So when we expand the view and think about plastic as an externality, there is a cost. There's a cost to the environment, there's a cost to human health, and there's a cost to non-human species that are also being affected by plastic waste. And we are generating a lot of plastic. So in 1970, the US generated 2.9 million tons of plastic waste, and plastic has only been commercialized, meaning that broadly distributed, since the 1960s. So you can see here in million metric tons of plastic in the US, it's significantly increased, and I don't have numbers after 2018. So we have a lot of plastic that we're producing. And we can think about the companies that are using plastic packaging and producing it. So the worst distributors, and this is statistics from Statista, which is actually a good resource that you have access to through our library on campus for any of your projects that you're going to do. This is metric tons of plastic. So Coca-Cola and PepsiCo, as well as Nestle, are some of the biggest producers of plastic. So when we think about these issues, we again can think about the effects on the non-human, the effects on humans, and we don't really know all of the health effects. There's new studies coming out about that. And we also have limited recycling capacity. So plastic can typically be recycled only 2 to 3 times. This is debated, but it can't be infinitely recycled. We know that it can't be recycled forever. And because each cycle degrades the quality and the strength of the material. So 79% of all plastic produced, according to the UN, has accumulated in landfills or nature. 12% has been incinerated, and less than 10% has been recycled. So this is really important to think about the plastic demand, meaning consumers are wanting things that are easy to access, and companies see this as a really inexpensive way to get their product to the consumer. So we see an increased demand and consumption of plastic. And that's expected to increase. So who's responsible for plastic? I want to ask that before I put the screen up. When you think about the challenges with plastic, who is responsible? Is it business? Is it the individual? Is it our government? Everyone's right here, is that we need an approach that holds companies accountable for reducing and having better plastic practices. Consumers, we can increase awareness and vote with our dollar and what we're choosing to engage in. And we need significant regulation that helps business shift. And we also need innovation on ways of doing new things. And we do have great examples of laws that are helping us move in that direction and forcing companies to have biodegradable containers, utensils, and biodegradable plastics. So I think one important thing here is that we really need that there's not one approach and that there are multiple truths here that exist at the same time. We need significant change. And when we think about what business is here, we have that consumer demand. They're demanding alternatives, reduction in plastic, and policy changes. And for business, policy change is a risk. It is something that right now, if we're talking about, the demand or the policy change in Hawaii, as well as the international treaty that we're negotiating right now, that business might have to really strongly innovate very quickly. And innovation can be a cost because it takes investment to innovate and develop those new technologies. So that's important. And I'm kind of glossing over that, but if you take my business and sustainability class at some point, we'll get into that quite a bit. And there's also opportunity here, developing new ways of doing things and taking the high road and meeting new consumer demand. Younger generations are very concerned about the environment, and they're very concerned about consumption. And governments really thinking about how to manage plastic. That is a significant issue for them, and also ensuring that companies are doing the right thing and setting the minimum standards around environmental waste. So right now there are UN-led talks in Geneva around plastics. And many countries see this as a significant issue. And these are some of the beautiful plastic statues that they've made there to call attention to how much waste there is. And importantly, some big oil nations are really wanting voluntary recycling to continue. And that, of course, is because they are able to generate a lot of money because of oil that's required for plastics. But there are new ways of doing business. So we can start thinking differently when we think about the environmental problems, and we start moving beyond that take, make, waste cycle and understanding that there is an end of life of a product that is not accounted for. One idea that's often talked about is people, profit, and planet that can lead to sustainability. So companies are not just thinking about their profit, they're also thinking about how their profit making and value creation activities affect people and affect the planet. John Elkington was a person that coined this term, the triple bottom line, so people, profit, planet. And John Elkington recently has said that we're not going far enough, that we are not meeting our goals around climate change. We're not meeting our waste reduction goals. So we really need to start thinking about this idea of regeneration. And regeneration is this idea that it's basically sustainability 2.0. It's not about sustaining the planet. It's about really kind of moving beyond and repairing the damage that we've done. And when we think about the triple bottom line and some of the issues that you brought up when I asked whose responsibility it is, we can think about this in kind of this cycle. One idea around thinking about just the consumer and increased consumer demand for responsible products and services, as well as developing responsible business practices, is this idea of conscious consumerism. So that focuses more on the consumer demand cycle that leads to responsible business practices. But we can also think about bigger systems change around moving to a circular economy. So circular economy at its basic level thinks about designing out waste. Why do we need waste in the first place? What can we do to completely eliminate waste? And anything produced should be designed to be taken apart and to be reincorporated into a biological cycle or a technical cycle. So again, you saw that in the Ellen MacArthur Foundation video. So it's really closing the loop on the way that we do things. And here's another view of that. So we have the technical cycle that all of the pieces in our electronics should be able to be completely reincorporated into the technical cycle, or other wastes that back into the biological cycle. So if we're thinking about plastics, and Ellen MacArthur also has an entire directive on how to develop a circular economy for plastics. We might think about biodegradable plastics, or being more innovative in how we can ensure that plastics or packaging can be infinitely recycled, and that we have really good infrastructure for that, meaning that we make it easy for consumers to recycle. The two of the biggest perspectives, again, designing out waste. We want to think about resilience through diversity. So that can be thinking about biodiversity and how we're sourcing our materials, ensuring that we're producing products with renewable energy, and thinking in systems. So closing that loop and thinking about where we are sourcing our materials from. So I only have a couple more minutes here, but this idea of regeneration that I mentioned earlier with the triple bottom line is other companies are going kind of thinking about the circular economy, but taking that idea of regeneration and integrating it into their business models and coming up with completely new products and new ways of doing things. One of the effects of climate change is that we're seeing species migration. And some of those species are lionfish and pythons, and this is particularly problematic in Florida. So this company called Inversa Leathers, is a leather supplier. So what they do is they work with local governments to help them manage invasive species, because those invasive species that aren't typically found in that environment, that might be migrating for climate reasons or other environmental disturbance reasons that I won't get into here. But overall, governments need assistance with this. So Inversa Leathers goes in and they eradicate or help eradicate these species by working with the local government and local communities. And then they use all the material from those animals to produce high quality leather goods, and that they ensure nothing goes to waste. So their idea is that they're restoring the environment while they're producing high quality leather goods. But there are lots of ideas when we start thinking about how we're going to manage our environment, how we're going to think about new ways of doing things here. And I mentioned the Ellen MacArthur Foundation, who has a directive on accelerating a circular economy for plastic packaging. So again, it's really about prioritizing the elimination of waste from design and thinking about what we call cradle to grave of the things that we're designing and the products that we're designing. So from design to grave or end of life of that product, that everything should be considered about being reincorporated and nothing goes to waste. So encouraging those reuse models and developing innovative materials. So new packaging designs, designs that are not plastic, and developing those closed use systems. So it's a complete redesign that values systems thinking. All right, so thank you very much.
Thank you all so much for your comments and questions. If you still have comments and questions, or if you think of something between now and your discussion section. Save those for the section. Extend a massive thank you to our panelists of experts this week. It was a really engaging panel, and I really appreciate all of your questions. So thank you all. And if you have any questions, feel free to email me. Bye, everybody.